Hi everyone, welcome to Pure Virtual C++ 2026. We're so excited to have our 7th annual free one-day virtual conference made for you, the C++ developers. My name is Sinem and I'm a product manager on the C++ team.
And I'm Mats and I'm another product manager on the Visual Studio team.
We have a lot of exciting content and talks available for you today across various different themes, including the AI native developer workflow, build faster, run faster, and modernizing C++. And we'll all be active in the chat.
So remember to get in the chat on YouTube and ask your questions. We have all the speakers will be listening in and answering the questions. We'll look at them too, and
yep.
we'll get in there and type away. So don't be shy. Get in the chat and just ask your questions. Let us know what you think, and we're going to be very happy to answer as much as we can throughout this conference.
Yeah. What Matt said. So for our first session of the day, we'll actually be starting with my session, which is on C++ semantic awareness in the CLI and how you can use C++ language services in the Copilot CLI. So I'll hand it off to myself to introduce the first session of the day. Hi, my name is Sina Makunja, and I'm a product manager on the C++ team. Today, I'm here to talk about how you can have access to the C++ semantic awareness in the GitHub Copilot CLI using the new Microsoft C++ language server. The new Microsoft C++ language server gives you access to language services that you would traditionally find in an IDE, but via the GitHub Copilot CLI, so that you can stay in the terminal workflow and still have access to the semantic operations that you're used to. The Copilot CLI is GitHub Copilot's command line chat and coding experience. It lets developers stay in the terminal while asking for explanations, performing edits, conducting investigations, and overall conducting workflows against a current repository. With the Microsoft C++ language server connected, Copilot CLI moves beyond text-only assistance and can use semantic operations like symbol resolution, references, and call graphs to provide and locate relevant context more directly, improving confidence in code changes and overall token usage and iteration time. To get started with the Microsoft C++ language server, you'll first need to install the server from the Copilot plugins marketplace. To do so, I'll type /plugin install cpp language server at Copilot plugins. And this will automatically bundle the C++ language server so that I'm always on the latest version that the marketplace is shipping. And so that way I don't have to worry about manually installing the npm package. After that, I just need to accept the EULA and sign in. And so in this case, if I were my first time going through this workflow, I would do npx at Microsoft cpp language server -- accept EULA and then -- login. And if I were going through the workflow for the first time, it would prompt me to log in with GitHub, but in this case, I'm already authenticated, so it'll just send that back to me. So at this point, the server is installed in Copilot CLI. What I'll need to do next before getting started with semantic operations is I'll need to load project build context so that these semantic features are available for my repo. To do that, I will need to configure the repository just like I would in an IDE to get access to semantic awareness. In this case, that usually means a compile commands.json file. The language server includes a skill to generate this for MS Build and CMake projects. So in this window, I have the Microsoft Calculator repo cloned, and this is the open source Windows Calculator app in a real production C++ code base that's actually built with MS Build and Visual Studio solutions. And so to generate compile commands in Visual Studio, I would typically right-click and configure the solution. To do a similar operation in the CLI, I can leverage the generate compile command skill. So to generate a compile command, I can just type load project, and it will automatically sort of detect that skill and perform the relevant operations to generate the compile commands. And then you'll want to, in general, refresh this as you would reconfigure in a typical project in Visual Studio or in VS Code. But this skill really removes that need for manual plumbing. Or if you prefer, you can continue to manually configure and provide your compile commands like you would in an IDE. And so as we see, the skill generates, and it's actually able to sort of like search through my directories and understand the relevant solutions, VCX projects, and be able to invoke the right compile commands appropriately. And so it finds the VCX project and SLNX files, and it's now sort of invoking that MS Build extractor to be able to do so. So it's asking me if I want to access the extractor sample. I'll say yes, and then it'll download that extractor, and it will go through the operations to pull out all the compile commands. And so it's generating the compile commands for me based on the calculator solutions and able to do that all for me from the GitHub Copilot CLI and eliminating that need for me to really manually configure this for my project. If you have a custom build, you can also go through the steps to generate a script similar to this that is all available in our repos README. And so as you can see, it says the project loaded successfully with 122 entries from the calculator solution with some exit missing XAML files. And so that's all good for purposes of being able to access my C++ semantic awareness. And I'm able to understand like what the scope is exactly. And so if I want to view the contents of this compile commands.json that it generated, I can actually just open VS Code, and it's able to actually generate a subdirectory called .mscppls. And this has the contents of my compile commands.json. And so I can also see that like this is all good for me for purposes of generating, and we're working to make this process even smoother. So stay tuned for updates in the config space as we move forward and try to address all these projects. I can also verify that the server is running via LSP logs. So basically checking to see if the C++ server is up and running, and that all looks good to go. And so I'm able to perform semantic queries now. So now we've configured this calculator project in Copilot CLI just like you would in an IDE. From here on, Copilot understands your C++ semantics and can surface this information via specific C++ tools, including finding references, tracing call graphs, finding definitions, and locating symbols. Now let's use these semantic tools for a real refactor. In the calculator, there is this 3 different functions that essentially do very duplicative logic. And so I think they'd be a good candidate for a single enum-backed model. And so I'd like to refactor actually set standard mode, set scientific mode, and set programmer mode to all be a set mode function that it calls upon. And so that logic is shared by one function rather than being invoked separately by 3 different models that are functions that are doing the exact same thing. So to do that, I can paste this prompt in chat, and it basically asks that there's these 3 different methods that share near identical logic, and I'd like them to be consolidated into a single set mode method, keeping the public methods as thin wrappers. I also asked the model to use LSP to find all references of the 3 methods and verify that the refactoring is safe. This is because the ability of the prompt calling the LSP tools is often up to the model, so I recommend appending this to prompts to increase the likelihood of them being utilized, or creating specific custom instructions in your repo or organization to invoke the tools for particular workflows if you find them to be relevant. And so as you can see, it sort of locates the relevant methods and is now performing LSP operations to verify that the refactoring is safe across Calculator Manager. And so it's found all the references for set standard mode, set scientific mode, and set programmer mode, and it is essentially doing a thorough check so that I can have access to all those references upfront rather than having the model sort of grep through various different files. It's able to have upfront locations of all the different symbols, and so it's able to have the full picture, and it implements the refactoring. So it updates the calculator manager.h file and then replaces the 3 method implementations in the .cpp file. And so it is able to update accordingly based on all the relevant context it has upfront and perform this refactoring safely. And so as I can see, it sort of switches out all the different set standard mode, set scientific mode, set programmer mode, and just has a single command that these set modes take. And it creates a new set mode that has all this logic implemented. And so I'd like to accept that. And that way it can sort of like verify that the code refactor has completed successfully, leaving me in the position to sort of review these changes and iterate with the prompt or code as necessary. And so it's asking if I'd like to build Calc Manager to verify it and compiles. I'll say just use diagnostics, or yeah, I don't want to perform a full build right now because that would be very time consuming. But basically I wanted to verify that the changes are successful, but we can use diagnostics to do that as well. So now that I've implemented the refactoring, I would like to actually see the refactorings that I could do to this send command function, because right now it returns void, but I'd actually like it to have some error handling now that I've done some refactoring where there's new commands that are being processed by the calculator. Semantic awareness in the CLI can also help with scoping refactors before you start them. For example, when I want to change a function signature, I want to understand the blast radius, who calls it, and what will break. Instead of the model grepping and hoping I caught everything, I can use these language service powered workflows to trace a full call graph. And so if I wanted to make a refactor to change the send command function to return an error code instead of void, I can ask the model to do that. I can say, I want to make send command return an error code instead of void. What are the outgoing calls? And then I'll ask it to use LSP tools again. And just so the model knows that I would prefer to use LSP tools to locate the outgoing calls rather than performing grep functions. And so this way, the model can actually sort of provide me with the call graph and the relative blast radius based on actual language services rather than sort of like searching through. So it seems to find the symbols and it looks for the outgoing calls from send command in calculatormanager.cpp, and it shows me all the different outgoing calls. And so it tells me that the function primarily delegates to mode setting helpers and repeatedly calls process commands. And so it helps me sort of understand like which functions would I need to update if I am updating the send command function, so I can understand a full end-to-end refactoring before I sort of like spend all this time actually getting into the weeds of it. And so that all looks good to me, and that way I have all the relevant context up front so that I can proceed with this refactoring while thinking it through with Copilot before actually performing it and hoping for the best. Today, we walk through the full path to get C++ semantic awareness in the Copilot CLI. First, installing the C++ language server via Copilot plugins, loading your build project context to configure the project via the generate compile command skill that's built into this plugin, executing a semantic-aware refactor using LSP tools, and scoping a signature change using call graph insights to understand impact before proceeding. The bigger message is simple. In the CLI, you don't have to choose between speed and correctness. With C++ language services connected, you can stay in the flow and still make decisions grounded in the actual code model. To wrap up, let's discuss how C++ semantic awareness is available across all editors to meet you wherever you are in your dev workflow, so you can apply this workflow in your own C++ code bases immediately. So the tools for C++ semantic awareness are not just limited to the GitHub Copilot CLI that we saw today. They are also available in Visual Studio if you prefer to have agentic workflows in Visual Studio or prefer to go to Visual Studio for specific operations. This is available primarily through the Find Symbol language agnostic tool that actually not only provides you symbol references and definitions for C++, but for any other language that supports LSP, including C# and TypeScript. We also have C++ tools that are specific to C++ for getting call hierarchies and getting class hierarchies, and these are available for you to manually enable whenever you have any sort of C++ project open. They're also available in VS Code via the C++ DevTools extension, which bundles with the C++ extension pack. So this should automatically install if you have that extension pack available in VS Code. Through that, there's a set of tools that allow you to navigate your project through DevTools, including getting call hierarchy, getting symbol info, and getting references. And so you're also able to have that same interface in VS Code if you were to want to perform LSP operations in VS Code. Finally, we have it in Copilot CLI, as we saw today, through the Microsoft C++ language server. And there's several different LSP operations that are available to you for you to use either through directly invoking, encouraging the model to use via custom instructions or prompting, or at your discretion being able to basically manually invoke with different symbols. And so we have go to definition, find references, hover, document symbol, workspace symbol, go to implementation, incoming and outgoing calls, and then rename operations. And so these are all available wherever you are, so you don't have to pick and choose between what editor you want to work in for what agentic workflow, you're able to have access to these tools across the board. So some tips for using LSP tools in the Copilot CLI are that we saw today how you generate compile commands.json using the extract compile commands skill. We recommend loading and reloading the project like you would in an IDE. So for example, if build flag changes, if you have configuration changes, so that it stays in touch with the latest IntelliSense, because the latest build context is essentially how it has the greatest semantic accuracy for your project. So I'd recommend sort of building up that skill, whether that be through generating it through the skill or through manually generating it through your build pipeline. As we saw today, different models are also more or less likely to call LSP tools. So to improve invocation, I would recommend appending use LSP tools in your prompt or generating custom instructions to sort of encourage that usage for the types of semantic operations that you find it more or less helpful in. Also, verify that the server is active via /LSP logs or /LSP show to debug as you sort of configure with the C++ language server in the CLI, since there's less of that UX component of having colorization, for example, as you would see in VS Code or Visual Studio. And lastly, I would recommend to reference symbol names where possible so that it has all the context that it needs to perform the LSP operation, and it's not guessing what needs to be updated. And I think that's just a general good prompting tip, is to be as specific as possible, especially when you're performing a large-scale refactor, so that you upfront understand exactly what you want to change and how you want the model to go about making these updates. So as you try out the Microsoft C++ language server, we'd love to hear your feedback, especially as we improve the performance around the C++ language server, extend capabilities, and improve the configuration experience to make it as smooth as possible for any C++ developer. As you have any sort of feature requests or issues you run into, we recommend filing issues in our GitHub repo, and that's aka.ms/ms-cpp-ls. Or you can look up the Microsoft/CPP language server on github.com. You can also fill out our survey and share your experience with us. We'd love to hear what's working well and where we can improve. That is available at aka.ms/ms-cpp-ls-survey. And you can provide sort of like a quick 3-question answer to how your experiences are going and how we can connect to learn more about where we can address your agentic workflows next. Thank you so much, and enjoy the rest of the conference.
That was an amazing feature.
Yeah.
And you know what I really like about this is that it works in Visual Studio, VS Code, and the CLI.
Yeah, and so you don't have to pick where you want to operate with GitHub Copilot. It's able to operate like an IDE across any editor that you choose.
Yeah, that's fantastic. One of the things that I really noticed here was the rename feature, because if you've been using Copilot over the years, from the beginning, as things have gotten better and better, one of the things that was a problem for a while was the rename, because you have to update all the references, and some of the references could be in like places that were not obvious to the LLMs. And now it just knows everything, and it can just do the right thing the first time, and you don't have to wait for it to like do a compilation that then fails, and then, oh yeah, there was another rename needed, and so that back and forth is now eliminated, and so I would assume that things are going to speed up a little bit because of this as well.
Yeah, and I think that effect will definitely compound as you are able to kick off more agentic workflows, because you have access to these LSP servers. So you'll have all that context up front, and then you can sort of have more concurrent workflows that will locate that context, perform relevant updates, and then you're sort of able to sort of charge up your developer productivity as a result. So definitely great to have across our editors.
Yeah, that's very cool.
Yeah. So up next is a talk from Victor, where he's going to talk about C++ and Rust interoperability. So I'll hand it off to Victor to talk about that.
Welcome, folks, to this session on C++ and Rust interop. So why are we discussing about these two things? Why C++ and Rust? Well, Rust code everywhere is increasing at an accelerated rate. But so does C++, and that's on top of gazillions lines of C++ out there anyway. So hybrid code bases are quickly becoming a thing. Whether we like it or not, this is where we're going to be for a while. So we need to learn to play nice together. having seamless interop between C++ and Rust components is essential for the success of the symbiosis. There are many challenges in this process, but people have found various ways to make things work, from dealing with ABI issues and compatibility, platform toolchain guarantees around languages, going now to C, FFI, various techniques and code generation crates and glue in between the two languages. But the problem is not fully solved. In general, when you ask people about what you think Rust C++ interop would mean, they would sort of throw a bunch of these keywords at you. And depending on their project needs and what they care about, it might be closer to one than the other. So I think it's more than that, actually. I think all these pieces matter. You can't just focus on the interop library itself, or just the compiler bits, or just the linker. You have to think about ABI guarantees. You have to think about debuggability of these hybrid projects. You have to think about packaging and deployment and build systems and how we integrate these things together so they have a smooth, coherent experience. So all these pieces matter. So I'm going to try to see how much we can cover today. We have just a short time together on this topic, but there's much more, and I can tease out more things you can look at. So what are you going to get out of this talk? I aim to highlight some of the major interop challenges we face today, existing solutions out there, and there are a bunch of them. And I'm going to tease out some of the avenues at the forefront of this pursuit, as in active experiments and new projects that try to solve this problem. I would say that general purpose interoperability that is not tied to a specific toolchain, IR, without loss of performance, because nobody wants that, has yet to be achieved. Just making things work in the problem space where C++ and Rust activate, it's not enough. As such, I think most of the solutions explored so far by the community fail to deliver on all the requirements, swinging a vast range from either being ergonomic but not as performant, or being very performance-minded but not very ergonomic to use. So I try to walk you through some of these things. So let's see. What's out there? Well, the original duct tape for this is C, of course, the lingua franca of FFI systems, languages. Every API consumable from most languages goes through some kind of C barrier, right? It's the only truly ABI stable universal interop glue, and everyone has been learning to use this over many, many years from various languages. But alas, it's not a very great abstraction. It doesn't provide any safety, and you're sort of forced to use naked structs everywhere, public fields only, have to deal with row pointers, manual management of lifetime, and so on. So it definitely lowers the semantics level at which you can operate. But many projects make it work. So for some interop needs, this might be just what you need. So let me introduce BindGen. Many of you probably heard of this tool, and you might be successfully using it. So this allows Rust code to call into C APIs that will take C headers and produce Rust FFI bindings out of there. I have a very simple example here on the slide. And this is a source generation. So it requires a special build step to do these transformations on your source code, right? And we have the other direction with C BindGen, which allows C code to call Rust APIs. So it will take your Rust RS files and generate C headers out of them. Of course, this again is a very similar process of source code generation, part of your build, but it does require that you take special care around your Rust FFI types and functions. So you have to deal with API and representation details. It can be a bit messy, but many people make it work. So it is both C BindGen. BindGen is a solution that serves well many projects. Let's look a bit into what you can do with it. So like I mentioned earlier, it works directly on source code files. So no IDL required, no separately managed description files. You have to integrate it as part of your build step, of course. And it can, in terms of types, deal with wrapper C, sort of C ABI representation. And it does allow pass by value. This will be a recurring topic that we'll analyze with each solution. So it allows pass by value for C types, basic things, but it's not enough for most cases. We see a lot of things here that are just not available in this toolbox. Structs with private fields, C++ classes, vocabulary types such as unique pointer, optional, or their Rust counterparts, box, and option. You cannot use really prevalent Rust features such as Rust enums, or the equivalent in C++ would be a standard variant. You can't use standard string or string slices or slices in general from Rust, because slice representation is not guaranteed. So this leads to potentially lots of complicated, unsafe code on the Rust side, some unsafe bits required here and there. And of course, you need to sort of convert to and from this C representation if you're actually have your code in C++. So it requires some scaffolding to make decent C++ interfaces. It lowers the semantic level at which you have to operate, but it might be just enough for some projects, depending on your Interop surface that you have. Enter a new project, CXX or CXX.rs. This one is a macro-based ideal thing. So you have to have a separately maintained some files where you describe through this special ideal language, you describe your FFI module, where you define the types that are sitting at the boundary of your interface layer, right? So this is where you define your structs and everything you plan to marshal across. And the tool will generate both representation, both for the C++ side and the Rust side, just like you see on this example. But this is a manually maintained thing. So you have to describe this Interop surface that you have. And you need to be very explicit about this API that you plan to share, right? So you can be very surgical and say, okay, I'm only exposing the bits that I care on both sides. And you can choose how you manage to present them, right? So that they can be consumed from either direction. So it's a bidirectional tool. So what does CXX get you out of the box? So again, you can deal with most standard types, slices, everything you put in your ideal definition in terms of structs, including user-defined things, C++ classes in general. You can have the usual suspects, vocabulary types that you would use, like unique pointer, optional, and the Rust counterparts like box and option. You can use standard strings on both sides of the Interop boundary, slices, vectors, everything you would expect. So it sort of checks a lot of boxes. And that's what it makes for a very popular solution for many Interop projects that sort of expect to operate at a higher semantic level than the bindgen, C-bindgen solution that we saw earlier. So it is very popular for this for this reason. So, and it's proven, as in both like C-bindgen and bindgen, all these solutions have been battle tested. A lot of projects out there are actually using, so they're robust. What CXX is intentionally restrictive and a bit opinionated, many people say. And as in, it makes some choices about how it tends to represent things and how it chooses to map semantic concepts from one language to another. So if you don't like these choices, or you find that you want to sort of stray from these hard-coded assumptions, it makes it almost impossible. So it's sort of, you have to take it all as you have to accept all the choices and trade-offs that the library has made. So CXX does not know about memory layout of user types, for example, and it doesn't allow, because of this, pass-by value. So in many cases, you have to use boxing, sort of put things on the heap, because you can't sort of directly put things on the stack or pass them by value. And this sort of makes it heavily rely on pinning on the Rust side, which sort of reduces ergonomics and makes it difficult to deal with callbacks, allocators, and similar things. I should mention, for people who are not very aware of this, pinning in Rust ensures that an object's address remains stable to support self-referential structures or foreign code assumptions, right? So it sort of forces Rust programmers to work in a pin style, constraining the natural idioms that are expected in Rust semantics around move and borrowing. So it's sort of infectious, right? When you sort of start to pin things around, it sort of infects the code around it. So it reduces ergonomics, but it can definitely be done, right? So enter Zengar. Zengar is a relatively newer Interop solution out there. And again, it's a custom ideal-based solution. You can see it there boxed on the right-hand side. And again, you describe your types and functions. But it has a sort of a new thing, and that is that layout annotation, where you can describe the layout of custom types, size, alignment, and things of this nature. And then, again, the tool generates all the required scaffolding on both sides. So again, this needs to be separately maintained and manually edited. So it's ideal for when you want to be very surgical about the Interop surface area, where you don't expect to just lift everything. It works with all the standard types, slices, everything you put in that ideal. And yes, we checked the box finally for pass by value, because we have added this annotation for types. And now the tool knows the layout and size of user-defined types. So no need for indirection or boxing any heap allocation. So yay performance. It also reduces the need for excessive pinning, like we've seen with CXX. So I would say overall, Zengar favors more Rust-friendly APIs and developer experience, accepting some occasional runtime cost here and there. And it's also a newer solution in the Interop space. So although it has many attractive qualities, it's not as battle-tested as the previous ones. So enter Qubit. This, again, is a bold new project with the goal of high-fidelity language interop between Rust and C++. It's a very tall order. And the aim here is that you don't want to be sort of very surgical about what types you declare at the interop boundary and say, these are my shared things, where you say, I want to lift the whole API, right? I want to have both languages have equal footing and lift everything to be accessible equally from both sides. So it's sort of blur the line language-wise. This is a very complicated thing because of C++ mostly. And it needs native compiler integration on both sides. So it works directly on source files, no ideal required to be manually edited. And it covers, like I said, the whole API surface, whereas the ideal-based solutions tend to be very targeted. In terms of compiler diversity, right now just Clang is supported, but there is an open window for other C++ compilers such as MSVC and GCC. And this is via the optional auto-IDL facility opening the C++ AST query interface to new compilers. It allows pass-by value because the compiler can introspect layout information. So that's good. In terms of processing, again, this intermediate IDL layer, it's sort of bring your own compiler kind of deal, where you can have Qubit use this as an intermediate step to do AST queries and decouple this from the current prototype implementation, which is based on Clang. So it sort of it is open for other C++ compilers. I would say projects in general have a very diverse range of interop needs. So it's very hard to find one solution fits all. And I would say we have on the one side what I call the ideal-based solutions like C++ and Zengar, which tend to be toolchain agnostic. You can be very specific about API bindings. You can reason about API stability and version resilience and dynamic linking and all these things that are attractive to many projects. Whereas on the other side of the spectrum, you have things like Rubit, which require tighter compiler integrations. So it's not one size fits all. And I think most of the complication comes out of the fact that many C++ features have no direct Rust equivalent. So I have here, hence the name of the talk, I have here just a couple of examples that can be problematic. So there's profound semantic differences between these language constructs. Rust semantics is very much a subset of C++ semantics. And generally, Rust is less expressive than C++, so that makes that using Rust code from C++ is easier, but using C++ code from Rust is much harder. So again, calling Rust from C++ is much easier. You can do it. Rust semantics are a subset. Rust strong type system provides guarantees, easy to grasp intended semantics of functions and types. The compiler can be queried for all the information that you need for this, sort of introspect everything, and derive the required traits and information on both sides. So this is definitely the happy path of the Interop story. The other way, calling C++ from Rust, it's much harder, sometimes even impossible. C++ features that don't have direct Rust equivalent, like, for example, function overloading. You have to deal with unsafe, some of the lifetimes complications, some aliasing for references that can cause all sorts of pains, and in general, dealing with movable types that are non-mem copy. Just focusing on function overloading as one example of this, many people say this is a sort of table stakes requirement, being able to call overload sets on the C++ side. And some folks say that we really need to have a way to semantically identify C++ overloads from Rust at language level. My take on this is that we have to resist temptation to complicate Rust too much for the sake of Interop and Interop alone. And I would urge you to look at how Carbon and Swift approach these matters. They're slightly different. And we have to think, can we really solve this outside the core language so that we don't hinder Rust powerful type inference with overloading? So again, many people claim that we already have a clunky way of simulating overloading in Rust, so we might as well go all the way and do it right. And there's experiments underway using traits and the splat feature and the overloaded macro that you can use to get this done. Again, these are in very early experimentation phase, so nothing you can use right away. But that's just to frame the problem. Another very important problem in this mix is movement or teleportation of in-memory. So object relocation, this is a particularly sensitive topic about handling C++ values because C++ in general treats all objects as conservatively considered non-relocatable. In contrast, a relocatable value would preserve its invariant, even if its bits are moved arbitrarily in memory. So, for example, a 32-bit integer is the same if you move the 4 bytes someplace else. C++ assumption of non-relocatable values hurts everyone for the benefit of a few questionable designs in code out there. I'm not saying they're not there, but in general, I think we can do without. So only a minority of C++ objects are genuinely non-relocatable. Some examples here. So relocating an object to a distinct physical location is a destructive move, right? You create the new object having the original value at the destination, and you have to destroy the original source object, sort of a two-step process. For a lot of types, such as containers, copying the bytes and discarding the source, if you have constructions that have no self-references or any funny business, no code needs to run when moving the inline portion of these values to a new location. So they're basically bitwise relocatable types. And that's a good thing. Many C++ libraries already optimize for such types, including standard library implementations. So trivial relocation mostly tries to standardize this optimization that's already common practice. Alas, we tried to do it for C++ 26, and we ran into many problems. So this was actually pulled out of the 26 draft at the very last minute. They a bunch of proposals actually around trivial relocatability. Some problems were identified a bit late in the process, so we erred on the cautious side. But there's still hope to get it someday. So C++ and Rust have opposite ways of handling moves. Rust very much likes to move by default and does memcopy of the bytes of the type, regardless of the type, and it renders the moved from object inaccessible through the type system. That's a hard no. Whereas C++ likes to copy by default, as we all know. And by default, you have these special move functions, constructors, and assignment. And for example, standard string cannot be memcopied due to small string optimization. It's self-referential in some implementations, not all. So again, it leaves the moved from value accessible to be destroyed at the end of the scope, which is slightly different semantics than the Rust side. Rust Pim solves this issue with self-referential types in a different way. It's definitely not ergonomic, but it's sort of outside the type system directly. Why do we care about this? We care about this because you cannot place a C++ object on the Rust stack because it cannot be safely memcopy moved or relocated in memory in general. That's why we needed these trivially relocatable or bitwise relocatable types that we aimed to introduce in C++ 26, and maybe we'll get in 29. That's the goal. You want to get to a place where you have the standard library to be mostly relocatable, most of the stuff there, like containers, be relocatable. And that would allow us to put most C++ types on the Rust stack. Rust loves the stack, so that leads to high efficiency at this interop boundary. And now, sort of, at the end, let's talk about the compilers a bit, because they play a big role in this story. There's many tricks that require deep compiler involvement. I mentioned earlier layout information. High fidelity language semantics and mapping of vocabulary types require involvements from front ends, both on C++ side and Rust side. And of course, we want to aim for toolchain independent IR. We don't want to sort of tie an interop solution to a specific compiler representation. We want to favor open solutions, extendable solutions that allow all compilers out there to interact on C++ and Rust side. So first, we care about binary level fidelity, ABI, codegen, linking, dynamic libraries, and all sorts of other things that require deep compiler integration. On the language side, I believe that C++ 26 reflection could be a game changer for Lang interop, and I'm not the only one. I highly recommend you watch Herb Sutter's keynote from last year's CPPCon, where he makes this as one of the working cases for C++ 26 reflection, having C++ as sort of the new lingua franca of interop across languages instead of C, because of reflection facilities that the language provides now. Of course, we cannot round off the whole interop story without addressing the ABI elephant in the room. I don't have time to go into this now, but you can definitely search for my name online and ABI, and you'll find more than you want to see. So if you care about these things and you want to get involved, there's been a lot of effort recently around this. So I can point you to where you can get involved. There's Rust Lang Zulip chat and a dedicated channel for interop. You'll find lots of familiar Rust and C++ names there. People that you might know are interested in this topic on both sides of the languages. And we had already a bunch of meetings, one of them very recently. There's extensive notes from these previous meetings, so you can catch up if you want. They're all accessible online. And if you care about this topic, do get involved. We welcome expertise for people and opinions, and we would like to build these solutions better together. Some final recommendations that you must watch. Fine-grained C++ Rust interop. This is sort of Kubit's take on the story. Very good presentation from last year's RustConf. And deep dive into Zengar, which I didn't have time to cover in depth today. but you can definitely learn a lot from this presentation by David Sank. All right, now I'm curious what you folks think about Interop, and sort of welcome you in chat and sort of interact with me either now or later online and discuss some of these things.
Hi.
That was great. I love that there's so much emphasis here on like how we can make different languages talk together in an easier way, because the fact is that most large solutions out there make use of different programming languages for different scenarios, and so having that interoperability there is really nice.
Yeah, I think, more and more we have to consider like how these languages do interact with each other. And so I think Victor did a really good job of sort of like laying out that solution space and the different considerations and sort of like the work that is being planned for like C++ 26 and moving forward to help that make it more compatible with other languages, which I think will benefit, all programmers anywhere they are in their language journey. So I think it was really great. Victor is great too. I mean, he's an expert in this. So
I learned a lot here. This was like a really good technical deep dive. I'm impressed. It was cool.
Yeah, I think it was great. So I think we're ready for our next session, which is on Augustin's going to be presenting on AI-driven C++ development in Visual Studio. So lots of great content there. I'll hand it off to Augustin to talk about that.
Hi. In this session, I'm going to talk to you about the latest AI features that are available in Visual Studio for C++ developers. My name is Augustin Popa, and I'm a product manager with the Microsoft C++ team. Over the past few years, we have been investing extensively in improving Visual Studio tooling to keep up with the latest trends in the industry to help you be as productive as possible. And in this session, I'm going to go over how you can use GitHub Copilot tooling that's built into Visual Studio to enhance your existing experience that you're already used to doing in the product. So I'm just going to go ahead and switch right into Visual Studio. All right, so I have Visual Studio here. It's opened, and I've already loaded a project. And this particular project is the Windows Terminal application. And if you're familiar with the Windows Terminal, it's the modern terminal that you have available now that you can use in Windows. And in this case, we have like the actual dev environment for it set up in Visual Studio, so we can build it and we can make changes to the code and interact with it. So it's a fairly large code base. There's a lot going on, and because it's a large and complex code base, there are various different issues and complexities that you have to deal with when you're trying to get this up and running in Visual Studio, especially if you're unfamiliar with this code base and trying to figure things out for the first time. So what I've done here, so I have the GitHub Copilot chat window open here on the left side, and if you're familiar with Copilot Chat, this is essentially the main place you'll be interacting in Visual Studio with our AI features, with GitHub Copilot, to do things like asking questions, to understand the code base, or ask it to actually perform different tasks for you that you would otherwise be doing manually, essentially. And over the past year, the GitHub Copilot Chat window has improved significantly. We've added a lot more functionality over time. And in particular, like if we look here in the bottom left, first we had the ask mode, which is essentially questions and answers, or essentially it's like an AI chat interface, right? So you can comment something and you can get a response. And then we added agent mode, and agent mode lets GitHub Copilot actually make changes in your project for you. So it doesn't just answer your questions for you to go and follow up on. It can actually go and make those changes for you while still giving you full control to take back any changes that you don't want, to see exactly what changed, to get like a diff view of what changed. There's an example here, like where it added this header file, and it's letting me keep or undo it essentially. And where I can look at a diff view side by side. And if I was dealing with multiple files, I would also have control over exactly like which changes I'm keeping and which changes I'm not keeping. And now we have some additional, tooling that we've added in Visual Studio. So after we added agent mode, we also had plan mode. This is useful if you have something very complex that you want Copilot to work on, and maybe you're a bit nervous about just letting an AI tool go and work on something big, and while you go and get coffee or something, and then you come back, and then you realize, oh, it did it wrong, and now I have to redo it, and I've burnt a bunch of tokens, and that's annoying. So with plan mode, you can build a plan first, iterate on that with Copilot, and then go and implement the plan. But then beyond that, more recently, we've been adding different built-in agents that perform specialized tasks in the IDE. And I've already run here one of them. So we have the build perf CPP agent. And this, so I've already run through this before we started here, because this does actually require rebuilding the project, which can take a while, and it actually rebuilds it several times. But this, what this agent does is it uses the existing tooling that we have built into the product. So some of you may be familiar with C++ Build Insights, which is a tool that you can use to analyze your build times with our MSVC compiler. And you can use that tool to figure out, okay, what's causing my build to take so long and how can I make it better? And that you have that functionality, but now it's built into GitHub Copilot as well. So all I did is I asked it a question, essentially, how can I improve my C++ build? Right, and you can say build perf CPP, where you can just select it from the dropdown, and then it knows, okay, I'm going to go and use this specialized agent, does a full build. It comes up with some thoughts about what are some optimizations we could make. Like, for example, we have a precompiled header file. Should we add some additional headers to that so that they get precompiled, and that will help with iterative builds in the future? It forms a plan for that, essentially, and it actually goes and implements the change, which is why we have this particular header being added here. Right, so, and then I can choose to keep or undo it, and I can also go back and iterate with Copilot and go back and forth in the chat, essentially, and decide if I'm happy or not. And it tests the before and after. It tells you if the build time has improved or if it's gotten worse, and you can basically keep experimenting with it until you get a result that you're happy with. So this is like having someone over your shoulder, essentially giving you advice and able to actually use the tooling within Visual Studio. So it's not just like it's just like reading code and giving you like a basic, here's what I think you could optimize. It's actually building the code, and it's actually analyzing the build times and giving you that before and after. And we've heard in the past from C++ developers, the second biggest problem that the C++ developers state that they have is managing large build times. So this tool is designed to help with that sort of thing. All right, now let's actually go ahead and we'll try just running this program. I've already built it. So let's just try running it and just see what happens. Okay, so I'm running with I'm starting to debugging session, and now you notice immediately I get an exception that's thrown here. Now I'm coming into this code base and I'm unfamiliar with it, and I see an exception immediately as I start running it. That's not great. That makes me a bit nervous. Like, what's going on here? Is the program completely broken? Like, can I still test it out? And you know, it seems kind of generic, like, oh, it's an exception thrown at this memory address in Windows terminal.exe, and there's like a specific type of exception, and it's not clear, like, what does that even actually mean? Well, now you can actually just click Analyze with Copilot, right? And then what this does is it goes to the GitHub Copilot chat interface, and it actually tries to figure out, okay, like, what's going on with this exception? Why am I hitting this? And it can pull information from your debugging session. So this is using another agent. So we just talked about the build performance agent. This is the debugger agent. So it automatically invoked that one because we're dealing with a runtime exception. And it's asking me if I want to include the debug output context so that it has more information to go on. And it can look at different bits of information, like, for example, the call stack. Right, and there's an Analyze with Copilot there as well. So if you're looking through the call stack and trying to find something, you can pass that over to Copilot and have Copilot look at it. And it's like having someone over your shoulder that's also looking at the same problem you are, and hopefully it's like two brains are better than one. That's kind of the thought here. But it's also very useful if you're just not very familiar with some Visual Studio features, or you don't use them a lot, or if it's just too much complexity because there's a lot of information to look at. Like every time you start debugging, you see all these different windows, diagnostic tools, and the call stack information. It's hard to keep up with everything that's going on, but this agent helps you make sense of all of it and simplify it down and call out the details that matter so that you can then go and focus on that rather than having to go and look through all of it manually by yourself. So that's essentially what's happening here, right? So it's reading through all of the different logs that are available here, and it's giving like regular status updates as it's progressing. And yeah, we're just going to wait and see here if it can figure out what's going on with this exception. If it's something serious, is it something I need to look at right away, or is it something else that's going on here? So, all right, so still going there for a bit. And while it's doing that, I did also want to call out a couple of other things here. So we have the different agents that are available here at the bottom, right? Also, remember, we do have a lot of different models that are available in Visual Studio. So right now, I happen to be running Claude Opus. It's a very, very powerful model, but you can go and change to different models depending on what you think works best for you. You have lots of different options, and we update these on a regular basis. Some models are cheaper than others if you're trying to minimize token cost, but maybe they might be a bit less accurate for certain tasks, so you can experiment with it and see what works. Or you can go for a more expensive model that will give you more accurate results. So in this case, I'm using one of the more expensive models. Okay, so it's mentioning that, so it's kind of giving some general information about this particular error message or this particular exception that was raised. And it's basically asking me if I want to do some deeper analysis. So I'm going to just ask it, will this block me from running my program? And let's see if it can come up with an answer there. So sometimes you get exceptions because something isn't loaded properly at the right time. Like we can see something went wrong here while initially running this program. So something perhaps didn't load properly, or there's some kind of bug somewhere. So I'm trying to figure out if it's something really serious, or if it's just something that I can basically skip over for now, because I'm really just trying to test out this program and see what's going on with it. And it looks like, yeah, this is like a standard exception that it catches internally all the time. It's not necessarily a bad thing. I have it set here to break when this particular exception type is thrown, so it's always going to break every time it comes up. So let's just try, if I just uncheck this so it doesn't break anymore on this exception, and I run it. Okay, and now we've run the Windows terminal. So this is like a developer built of Windows terminal rather than like the usual release one you might be using. You might notice the background color here looks very different than what you're used to. What I tried to do here is to configure my background color for the terminal so that it looks a certain way, but it doesn't really look right to me. So like let's actually go and see how this is configured. So if I go to the settings, and again, this is like the actual program that I've built in Visual Studio, I can actually open a JSON file so I can look through the GUI, where I can look through the JSON file. I'm just going to look at the JSON file, and I can see the background color here is set. And I have this open in Visual Studio Code, which gives you a nice preview of what each like hex code for each color actually looks like. And I can see that this is actually supposed to be blue. Okay, so something is off here. It's not really giving me like the correct color. Like it looks more green than blue. So it looks like there's some sort of bug that's going on here. So we're going to try to figure out what I need to do basically to fix that. So we will, let's actually start by just asking Copilot for a little bit of information. So like in ask mode, you can use it to ask questions just to get an understanding of the code base and what is going on there. So I can say something like, how does this code base parse a hex color string, like, and then I'll put like the specific one that I was trying to use into a color, let's say into a color value, and then what function handles it and where is it called from. Okay, so I'm just trying to get an understanding from like where in the code is this actually being decided? Like what's determining how to actually process this color? Because there seems to be something wrong with it. It's not giving me the color I'm expecting. So again, now I'm really just asking it for some information at this point, because I switched to the ask mode. Copilot can adapt on demand. Like if you ask it to go and like analyze the build performance or something, or to debug something, like it can switch to the different agents and confirm with you if that's what you want to do, just based on the context of what you're actually typing, or you can just like explicitly switch to a particular type of agent, or you can just do at the name of the agent as well if you want to be explicit about exactly what you want. So what's happening here, okay, so Copilot is trying to figure out, okay, like where in the code. So I started with kind of a very open-ended question because I don't have a lot of context other than the fact that this particular color is not rendering correctly, right? So it's trying to figure out, okay, like where in the code is this happening? And it's actually using the semantic intelligence that's available in the Visual Studio IDE to help find that answer. So rather than just doing like a Control F kind of search for something, or like a really basic textual search, which it can't really do anyway because I don't have enough context even in this prompt for it to be able to do that. It's going to try to actually use essentially like the intelligence engine that runs behind the scenes in Visual Studio, and that actually tracks all the elements of the code, like all the different symbols and how they connect to each other, to try to figure out which is the right one, where is it called. So like essentially it's running find all references behind the scenes right now. So it looks like it found a particular function and now it's doing find all references on it because I mentioned where is the function called from. So that's not like a Control F kind of search. It's actually like the find all references feature that you're using in Visual Studio. It takes a bit longer to run, but it's also accurate. And this blends like the kind of determinism that you're used to when you're working in Visual Studio yourself, right, with the flexibility and open-ended nature of interacting with AI. So it's really easy for you to get started and ask it to do something, but it's still behind the scenes follows the right sequence of steps that you would want to follow if you were doing this yourself to make sure you get to the accurate result. And it looks like it did actually find a particular location in the code where there's an issue and there's something going on with the way these bytes are being they're basically being offset, and it's causing the green to be swapped, or rather, I want to have a blue color and I'm getting a green color, so they're basically getting swapped there. So it has a suggestion for how to fix it already, basically, just from this context alone. I didn't even actually mention yet that there is a bug, but it kind of read through the code and realized, hey, there might be a bug here. Okay, but let's pretend it didn't even find the bug. Okay, let's pretend like it just told me the location, and I have to figure out like, okay, like how do I fix this bug? So I'm actually going to go and just like reset the whole chat. Okay, so it's like, okay, let's pretend the Copilot has no context on all of this, and instead, I'm going to try to use a different agent here to get me to actually be able to fix this bug. Okay, so yeah, so we have right. So I'm going to ask it essentially. I'm actually going to switch to the debugger agent, and the debugger agent, of course, is for debugging, as you might imagine. And I'm just going to go ahead and ask it, can you fix the bug I am getting where the background colors set in my settings.json are getting swapped. I am seeing the wrong color on the screen. So let's just go ahead and ask it to look into that. And I might, and you know, I'm obviously being very vague here in my prompt, so you can interact with it and you can go back and forth with it if it's like, if I'm just being too vague and it doesn't have enough context. So there are some different, this is a very interactive process, basically. And it's the way that to think about AI is it's not really like a magic wand. It's not there. It's like you just give it something to do and then it just does it and you're done and you can go home. You often have to iterate with it and go back and forth with it and essentially reason with it until you get to an answer that seems like the correct one. So it's going through here. So again, it figured out, okay, it looks like it's located in this particular function, the color from hex string. It has a hypothesis, like this is where the problem is, and this is the change that we need to make, or we need to change some numbers there. And then it has repro, so it wrote down the repro steps, like here's step by step what you need to do to get this problem. And then it's asking me, would you like me to start debugging to validate this hypothesis? So I can say, yeah, start debugging. Okay, and this is where things get really interesting, because now this isn't just a chat interface. Okay, it's not just like reading the code and trying to guess what's going on. It's actually going to run the debugger and step through and try to figure out, okay, like exactly what's changing where, and if I make the change that I have in my hypothesis, is that actually going to fix the problem? So essentially, it's going through that workflow of debugging that you probably do all the time when you have to deal with bugs, but it's just automated now. It's like it's done through GitHub Copilot. So not only will it give you a lot of information about what it found and what it and its thought process and the step-by-step, but it can actually go and perform the tasks. And the tasks go beyond just, I'm going to go edit your code. It actually is testing that it's doing what it's supposed to. So you can see it started debugging. My terminal is open again, right? And it's mentioning that, yeah, green and blue are read from swapped offsets, exactly as hypothesized. And now it's continuing the process. So now that it was able to repro the bug, it's now going to work on actually doing the fix. So, and hopefully be able to actually fix that color there. So it's just going to go ahead and run a little bit in the background there. And while it does that, we should be able to go and make that change, and then we can see if it worked or not. Oh, actually, sorry, I just realized. So yes, I reproduced the issue. So it was actually asking me for input there. So I verified when I ran the actual program that I was getting indeed the green screen, right? That's the issue that we were talking about. And now that I've confirmed that, yes, I do in fact have this issue, like it thought it through correctly and it has the correct repro steps, then it's going to suggest applying a fix. And I'm going to say, yes, go ahead and apply that fix, right? And then it should be able to go ahead and make the actual change. And let me just clean up the UI a little bit here so we can see. And you can see it went ahead, it found the file, it made this change to this file. It shows you the diff view, right, the before and after. And now it's starting a debug session again to see if the change actually fixed the issue. So, and the other thing that's worth mentioning as well is it will use various like advanced debugging features. Like it will try, for example, to use hot reload sometimes. In this case, it actually recognized that hot reload won't work in this particular project. If it tries hot reload and it doesn't work, you can also go back and correct it, right? You can tell it, hey, do this differently. But in this case, it looks like, it made the correct decision there, and now it's running through it again. It says that it verified the fix, and there we go. And we can see now the background color is blue, which matches what I would expect based on the setting that I had set there. So the bug is now fixed. Awesome. Okay, and we can go ahead and just like keep the changes here. Also worth mentioning while we have this open, right? So like if I wanted to change this manually, let's say, you can actually see as I'm typing stuff, right? Copilot auto-completion can step in and try to guess like what you were trying to say, essentially, right? And it can suggest changes in your code line by line, but also across multiple lines in the same file. So we have a feature called Next Edit Suggestions, and what that basically does is like sometimes you make a change in one line, and then it will realize, oh, this will impact another line, like another line that's way further down in the same file. So let's change that line as well. And it can make suggestions like that, which goes above and beyond the traditional completion experience, which basically would go word by word. Maybe it might add some braces and a single word or something like that, but it didn't really go further than that. Now it's capable of doing a lot more. And it can add like whole code blocks as well in some cases, depending on what you're trying to do. If it looks like something that's been done before, that's relatively simple. And there I was just making sure that I didn't just break something when I was fiddling around with the code. Okay, so I am seeing the blue background color. That's good. And let's actually, let's try something else. I'm gonna go back to, let's just go back to like the ask mode and say, explain this function. So this was the function that we were modifying. I want to try to get a sense of like, what is actually going on here, and how does Copilot think about it? So you might notice there's a little line there that says read skill explain CPP. So what I've done here is I've actually customized my Copilot environment in VS. So one of the big things we've been working on over the past year is making the AI experience in Visual Studio a lot more customizable. So I showed you some of the built-in agents that we have, right? You can actually add your own custom agents as well. So if you want to do something a little bit different, like for example, we have a built-in test agent, but maybe you're using a different test framework that works a bit differently, and the default experience is not going to be good enough. So you can go and build your own and have your own agent for handling that, which is tailored to your particular workspace. And that's fine and good for agents. And you can also connect to MCP servers, which are even more heavy duty. Like for example, Microsoft, we will connect, like we use GitHub and Azure DevOps all the time, and we have MCP servers that we connect to for that. Or if we're getting data from like emails or something, right, we can have MCP servers for that. But the most lightweight, like simple way to really customize your experience is probably to use skills. So if you click like this little like tools button at the bottom, you can see the built-in tools that we have for GitHub Copilot, including like the semantic intelligence tools we talked about that can find things like call hierarchy and class hierarchy information. But you can also add your own custom skills. Okay, so I have a skill called explain CPP, and what this is doing is it's defining a format for how I want Copilot to explain functions to me. Okay, so if I look at what it's saying here, it gives me the signature, it tells me what it does, it gives me edge cases and errors, and then where is it called? Okay, so the reason it's using this specific format is because I told it to use this specific format. Now, by default, it does a pretty good job of summarizing information for you based on your prompt. But if you're looking for like a very specific way for a specific type of behavior, you can define skills, right? And skills, you can have lots of different skills for different things that you do on a regular basis. And the nice thing about using a skill is that it doesn't take up a lot of context window for Copilot by default. So like a skill has a name and it has a description. Copilot always has that in its context window, so it knows to look up a particular skill. And it only loads the skill if it determines that you're actually asking for something that requires the use of that skill. If you might also be familiar with custom instructions files. You can have those as well. It's like a repo-wide file that's always fed into the context window for Copilot. So if you're doing something all the time, maybe you put it in your repo's custom instructions file. But if you have a task that you only do sometimes, and you don't want Copilot to always have like the details of how that works in its context window, you can set that up as a skill instead. And this allows you to reach a point where you can have lots of skills. You can have dozens of skills, and you're not loading all of them into context at once. You're just loading essentially the name and description so that Copilot can call them on demand based on what you're asking it to do. So it's a lot of customizability here, and this is quite powerful. It can save you tokens, and it allows you to avoid running out of context space and still get like really accurate results that are tailored to whatever it is that you want to do. Now let's look at one more agent here. Okay, so we have a profiler agent as well, and I can say like I can say add profiler or selected at the bottom. Analyze the startup time of this application. And so this is another agentic experience, right? So we talked about build performance, we talked about debugging. We also have one for modernizing your code, by the way, that if you're looking to move from an old MSVC compiler version to a new one. And all of these like agents can actually go and do things in the IDE. They can edit code, but then they can also run the tooling in the IDE to go and perform the different tasks. Like they can run builds, they can run the debugger, right? Depending on the agent that you're using. In this case, it's running the profiler, and we can profile the things like CPU usage, memory usage, and understand like how is this program performing. And if you have a particular problem you're trying to solve, this can be useful because you can iterate with Copilot, right? And you can just have it. You can just ask it to go and look at something. So in this case, it's startup, right? So, okay, we're going to just run this. So it runs this application, and it's collecting like a a bunch of data about the performance of the application, right? I can then click stop collection because I'm done running it. I have the information that I need there. And it produces a report which I can save and look at by myself, right? But it also feeds that information to Copilot. So Copilot then starts doing some research to figure out, okay, what's potentially slowing this down? Is there anything we can optimize? And it can actually suggest next steps. So like, for example, it has follow-up prompts that it puts at the bottom, and it can say, hey, you can look at the colors of this particular function because it looks like we're wasting a lot of CPU on this, right? Or you can investigate this other thing. Or we can look, or it might say something like, hey, let's look at the memory usage maybe. There might be something going on there, right? So you can interact with it, and based on what it's finding, you can go and try to diagnose the issue. And then, of course, you can work with Copilot to actually implement fixes and then test if you're getting better results after the fix or not. So just like we had the build performance agent, this is like a runtime performance agent, right, for your actual application. Okay, but there's actually more you can do with this. Let's just clean up our UI here. So if I open the test explorer, I have unit tests in this project, right? I can actually right-click a unit test that looks like has run successfully in the past. And you'll notice there's a debug with Copilot, right? So if your unit test is failing and you're trying to figure out what's going on, you can debug it with Copilot, and that's going to use the debug agent. Or you can do profile with Copilot, right, which is the agent we're using now. And this will try to run this particular unit test and give you that runtime analysis, the performance analysis for that unit test, right, for whatever task is being performed that where that test is being run. So this gives you a much more granular view. Like you can be very specific about, I want to test this particular thing. I know this particular task that I have a test on is running really slowly or it's taking up too much memory or something. And you can go and interact with it with Copilot, and it can go and do the same thing essentially, right? It can produce a report, and it can make suggestions if it thinks there is something that it can improve. So it does like a whole analysis, and right, it's saying like, okay, where's the CPU usage going? Is there something that we can optimize here, or is the performance problem somewhere else, and maybe we need to investigate some other part of the code or some other test. So you can do this and go back and forth with it essentially. All right, and that about wraps things up. So going back here to our key takeaways. So with Visual Studio and Copilot, it lets you take advantage of the reliable tooling that's built into the IDE that's been available for a long time now, right? That you can use manually anytime and you can continue to use. But now it can be enhanced with this AI assistant, right? With Copilot. So you have different entry points when you're interacting with some aspect of your like developer tasks in the IDE. You can feed that information to Copilot and you can work with different Copilot agents to actually fix the problem that you're trying to fix. Copilot is helpful for a few different things. It can help you understand unfamiliar code or unfamiliar IDE features as well. Like if you're overwhelmed by the GUI of like the profiler or the debugger, right? Like you can work with Copilot to understand it. But also Copilot is able to process large amounts of information at once, right? So maybe you don't have time to go read through all the entire call stack, right? But Copilot can do that really quickly. And it can call out, like, here are the little bits that you have to actually pay attention to and summarize it for you. And it can suggest next steps. So it's like a great peer programming experience to help you make progress quickly and get unblocked on whatever task that you happen to want to do. And in addition, it's all highly customizable. We've invested a lot in this customizability. You can bring your own MCP servers. You can bring your own models. Like if you don't want to use one of the built-in models, that's also something you can do. Like if you want to use like an open source model or something. You can, we talked about skills, right, which are a very lightweight way of customizing your experience. You have custom instructions files. And of course, you can build your own agents as well, like if you want like an alternative to what was already built into Visual Studio. But there's also a number of built-in ones that are really good as well. And Visual Studio is continuing to evolve fast, so you can expect something new every month. We ship monthly now. And it has improved a lot in the past 6 months. So even if you haven't looked at the new features in Visual Studio for a while, a lot has probably changed. We suggest following our blog at devblogs.microsoft.com/cpp blog. We post a lot of announcements there if you want to learn more.
That was absolutely fantastic. And I love seeing how Visual Studio makes it possible to do those things that were really hard to do before. Especially when it comes to debugging and profiling, which, it's kind of advanced concepts. And even though we have had tooling for a long time that makes it easy to debug and so on, there's like always that time when debugging is really hard, right? And you don't know how to solve that problem. And maybe there's someone on your team that you go to and say, hey, can you help me debug this? Like some expert that know all about debugging, like really deep, low-level stuff, right? And what Copilot does is that it now enables us to be that expert, right? Instead of having to go to colleagues or give up maybe or something like that, we can now go that extra mile that we wouldn't have been able to before. But also, on top of that, we can do things much faster. So even if we were experts in debugging and profiling, having that Copilot layer on top really just makes everything faster, and we can maybe profile more things than we otherwise would have done. And that's great. And so the support in Visual Studio for the C++ debugger and profiling and all that is very, very complete. And it's great to see.
Yeah, I agree. I think it's awesome that, we have those integrations so that you can have that like Visual Studio agentic workflow where you can invoke the debugger, you can profile your project, and so it feels very complete. And so wherever you are, like whatever process you're accomplishing, you are able to have like customizable agentic support, which is really, really great. I thought it was really great too that Augustin called out all the customizability that exists in Visual Studio. And so I think more and more, developers are wanting to customize, I want to bring my own model. I want, a specific skill for my repo that does this specific thing. And so I think it's great that Visual Studio is able to natively support all of those customizabilities so that, you're able to develop that all within Visual Studio and extend those for your agentic workflows.
And tie everything together. So Augustin was showing how you can go from a unit test and launch straight into the debugger agent or the profiling agent. But you can also just launch into the debugger or to the profiler without the agent, and you can attach the agent later on once you've done your profiling session, for instance, and you might get stuck or you don't know how to interpret the results, for instance. And so you can do it all in whatever speed you want and however much you want to take advantage of AI up front or later on, or it's all up to you. And Visual Studio just supports it throughout, like from unit test to debugging to profiling and so on. It's great.
Yeah, I think one other thing I wanted to call out too is just like what Augustin said at the end, which is that Visual Studio is becoming more and more AI forward and native, and so there's monthly updates, and you can see them in the Visual Studio blog where there's a lot of like new features being pushed to Visual Studio to keep up with how these innovations are changing month over month. And so it's really great to see that Visual Studio is iterating rapidly to keep up with the current trends.
And if you want to move even faster, we have the Insiders build of Visual Studio. So Visual Studio Stable is released every month. There's a new feature update. And the Insiders is basically what's coming out in the next stable. So you're up to a month early on some of these features, and it's updated like about every week. So if you want to get in and get to all these features as early as possible going forward, check out visualstudio.com/insiders.
Yes, yeah, I definitely use Insiders, and it's great to sort of have the latest bits. So great to have all of that available to me. Up next, we actually have a session that's going to expand on some of what was introduced before, which is that build performance agent. And so we will have David Lee's session on cutting your build times without becoming a build expert. So I'll hand it off to David to talk more about that.
Hi, everyone. I'm David Lee, a senior product manager on the Visual C++ team. Today, I will show you how to cut your build times with the help of GitHub Copilot Build Performance for Windows. You know the moment. You change a few lines of code, you hit build, and you go and get a coffee. Slow C++ builds are an age-old nuisance. They break your flow, they drain your day, and at scale, they cost real money. For years, the way you fixed this was to hand it to a specialist, a build engineer who could read a trace and manually optimize your code base. Today, I want to show you how you can do that work yourself. We can let GitHub Copilot do the heavy lifting with you making every call. To show you how all this works, I will demonstrate with two scenarios. First, a standard analysis that improves the full build time. Then, we will explore a scenario where we can also optimize the incremental build time, improving your day-to-day work. Before we dive into the demos, let's get started with a quick overview of how we got here. None of this appeared overnight. The entire workflow not only stands on years of foundation, but every layer has made this power a little more accessible. It started with VC-Perf. For the first time, you could capture what really happens inside a C++ build. Every include, every template, every function. But to read a trace, you had to use Windows Performance Analyzer, or WPA. And that required a steep level of learning. The power to optimize your codebase was there, but the access was not. Then came our C++ Build Insights SDK. With the SDK, more analyses became available to you on the command line. While these are more than raw traces, you still have to rely on expert knowledge to use these building blocks to create analyzers. Next, as one of our top requested developer community tickets, we brought Build Insights into Visual Studio 2022. We finally gave you readable views that can take you directly to the code without leaving Visual Studio. No more separate tools, no more context switching. And this year, we're adding the next layer. GitHub Copilot Build Performance for Windows. It sits on that same trusted foundation by putting an AI-powered build engineer on top of the process. You can now steer in plain language. All this is possible with Microsoft C++ Build Tools Trace Capture Technology, VC-Perf. It works for both CMake and MS Build projects building with MSVC. So, what does this new process look like inside Visual Studio? Let me show you the various ways to get started. For this demo, we'll use VTK, an open source C++ library for 3D computer graphics, image processing, and scientific data visualization. The easiest and the one I recommend is just asking Copilot. Open Copilot Chat. Select the @BuildPerfCpp responder and say, make my build faster, or click one of the default prompts. That's it. If you have multiple projects, you can either specify your project from the prompt, or right-click your projects, choose Run Build Insights, and improve build performance. Prefer the menus? You can also go to Build, Run Build Insights on Solution, improve build performance to analyze the whole solution at once. And if you already completed a trace and have a Build Insights report open, there's an Improve icon right there. Click on that to start the optimization process. However you start, it is a conversation, not a black box. Copilot proposed changes that you approve. At every step of the way, you can decide what to keep. So let me kick it off with a prompt and show you how it works. In this C++ project, our build takes longer than anyone wants. Let's focus on one of the projects to see if there are any optimization opportunities. We will tell Copilot optimize Common Core. Because we have asked it to analyze a specific project, Copilot will perform build analysis only on Common Core. The first thing that Copilot will do is running a full build to capture an ETL trace. This first build establishes baseline and provides hotspot information for Copilot to analyze. After the trace capture is complete, Copilot will analyze and surface the hotspots in the code. It will provide you with a plan of action. When we look at the plan, we'll see that Copilot has identified expensive headers. In our case, we see how the entire F-stream include chain is expensive, costing seconds every time you build. Next, Copilot proposes targeted fixes. As you can see, it suggests a precompiled header or PCH. With PCH, you can compile it once or reuse it everywhere, and that cost you were paying on every header disappears. Copilot will then apply the suggestions and verify that the build works correctly. If the build breaks, that is okay. Copilot will keep iterating until the build succeeds. And once the build succeeds, Copilot will present you with its findings and a before and after report. At the end of after roughly 30 minutes, we now see a list of headers that were folded into a PCH. We also see that Copilot found the F-stream include chain contained 7 headers that consume roughly 15% of build time. So after the optimization, the Common Core project received a 43.5 build time reduction, roughly 2 minutes. Here is where you stay in control. Every change is a suggestion that you can take or leave. In this case, the PCH suggestions make sense and improve the build times meaningfully. Let's keep the changes. That's a full loop. Capture, fix, and verify. Now, let me show you a different scenario. Sometimes Copilot will observe optimizations that impact the build times negatively. In those cases, Copilot will ask your permission to investigate iterative builds. Let's kickstart the conversation by using the menu entry this time. In this demo, we will use the open source project SQLite Flux, a modern C++20 SQLite query builder. We will start the session to see what Copilot suggests as an optimization plan. As before, the agent has found optimization opportunities via PCH. We can see that Copilot detected 4 header hotspots. With the plan in mind, Copilot will then apply the fixes and rebuild to verify the improvement. However, while measuring the before and after numbers, the agent noticed that the build has regressed slightly. When the full build regresses, the iterative build tool kicks in. Copilot will consider a few different attempts at optimizations. It will verify if any of these optimizations still make your day-to-day incremental builds faster. After approving, Copilot measures each one like an experiment a build engineer would run. After roughly 5 minutes, we have the final report. Roughly 50% faster incremental builds. These incremental builds that you run dozens of times a day are now noticeably faster. As a trade-off, our full build for SQLite Flux is a touch slower. Now you're given a choice. You might want one set of optimizations for daily work and a different set for shipping or CI. Copilot now puts the decision in front of you. You stay in control. You can create or pick a config that fits how you and your devs actually build. So let me put this all together. 1. Copilot finds and fixes the real bottlenecks. The expensive headers, the heavy templates, the things that used to take an enormous effort to hunt down are now accomplished in minutes. 2. Every change is measured. Before and after, every time. Copilot shows the change list, roasts back what hurts, and is honest about the trade-offs in between. 3, you stay in control. Copilot does the heavy lifting, but you make the final call. Slow builds do not have to be the price of writing C++. With GitHub Copilot build performance for Windows, you can move as fast as a dedicated build engineer. In our first demo with VTK, we received meaningful results that improved our build time. Working with the maintainers, we have submitted a PR that was successfully merged into the repo. The analysis that the agent gave resulted in real-world impact. You can find GitHub Copilot build performance for Windows and Visual Studio 2026. Built on the foundation we have spent years making more accessible. Start a chat with the @BuildPerfCPP agent, or right-click your project to try on your own build. For more information, please visit aka.ms/virtualcpp/BuildPerfCPP. Thanks for watching.
This is great to see build times being optimized. It's so important when we're, writing our code and building to verify and debug and all those things. What we call our inner loop becomes as fast and efficient as possible. And a feature like this is exactly what is needed for this to be as best as possible.
Yeah, I think it's great even if you shave off a couple minutes, that compounds very quickly if you're running a lot of builds in a week and you're editing your code and you're able to sort of again, go through that inner dev loop more optimally, essentially. And so I also thought it was great that, this agent takes into context some of the build insights and that deterministic tooling and turns that into actionable improvements tailored to your repository. So if you have different precompiled headers, it is able to provide you with something that you can just review rather than having to, take that output and digest it and apply to your code base. It really lets you iterate with the agent so that you can optimize your build. So I think that's really great to see as well.
It's nice how all the different components of Visual Studio all comes together, right? When you're using the different agents, it's really it understands the full context of what's available and gives you all that richness and additional context to make it as good as it possibly can be.
Yeah.
And we've even used this internally as well. So this is something we use to, just like we use the debugger agent and we use the profiler agent to find perf issues in Visual Studio itself. We also use the build tools here, or the build optimization agents here for our own internal stuff. So this is absolutely great stuff.
Yeah, definitely. And it definitely helps our teams, build faster, edit faster, and go through all of that in a quicker manner. So definitely recommend checking out the build performance agent in Visual Studio and seeing how it works with your C++ code base.
Yep.
On that topic of actually building faster and being more optimized, we actually have the next session, which is our last session of the day, which is on building faster and smaller with C++ 20 modules, presented by Ryan Shepard. So excited to see how the Windows runtime team adopted them to build faster and run faster. So yeah, take it away, Ryan.
Hello and welcome. We're going to learn today how you can speed up your build and trim gigabytes of build output by updating C++ WinRT to version 3.0 and adopting its new module support. So check this out. Yeah, spoiler alert. I'm skipping directly to the victory party at the end of the story. While developing the modules functionality in C++ WinRT, I forked Windows Terminal. Yeah, that Windows Terminal, the big one everybody uses. And I used it as a proving ground for the code, making sure that things worked, that it was actually going to function properly on a real-world project that heavily uses C++ WinRT. I wanted to make sure, I was hoping I wouldn't regress things, basically. I was pleasantly surprised to find out that I hadn't actually regressed the build performance at all, but it improved more than expected. So you can see here, the build clock wall time went from 9 minutes, 19 seconds down to 7 minutes, 30 seconds. That was an improvement of nearly 20%. On another machine, it went from 12 to 10. On another machine, it went from 20 minutes to 18 minutes. It was a similar story across the board, consistent like 15% time gains. And the disk savings were massive. We went from 30 gigs down to about 18 gigs in the object folder. This is a huge win. This is impactful. It can matter a lot when you're running CI builds on things like cloud images, where storage space can be a little more scarce than your typical desktop, monster terabyte drive. This is impactful. It can lead you to, you can use smaller, less expensive images, things like that. And to be clear, this was just purely an exercise in trying to convert all the C++ WinRT projects to using C++ 20 modules. I didn't try to attack any other low-hanging fruit. I didn't do any other build optimizations. I didn't try to modularize any of the other libraries to get further wins out of this technology. This was just, hey, cool, it works. Things seem to be functional. Let's go. Let's walk away and move on to the next project. I don't normally work on terminal. That's all it was there for. So it's pretty exciting stuff. My teammates were pretty happy to see it. It really removes a lot of complications and being able to set up build agents and things like that when you don't have to reserve an extra special image with tons of disk space just to run your CI builds. So how did we get here? Well, there we go. So C++ WinRT 2.0, you include these generated projection headers. CPP WinRT, it generates headers from Windows metadata, aka WinMD files. These headers contain all the machinery for you to use these rich WinRT APIs in a modern, idiomatic way. All that goodness isn't cheap, especially when you're building large namespaces, large class hierarchies, lots of APIs, like the old days of flat C APIs when you had just a few forward declarations and header, and all the real heavy lifting, all the heavy complexity was hidden behind a library. That doesn't really work, as we all know, when you're using template metaprogramming. When you're using templates, generally the compiler has to see all the type definitions. So we have all these header-only libraries. C++ WinRT is yet another example of a header-only library. That stuff is expensive. It's very large and complex to compile. These header files, they need to be visible in every single translation unit. That's a drag. You can save time in a project by putting them into what's called a precompiled header. That means you only have to build them once per project. These precompiled headers, they're big and heavy though. You throw a single windows.ui.xaml.h header into there, and you're immediately talking well over a gig of disk space, for processing that header. This has been a common pain point for years in C++ WinRT. These PCHs, they're monolithic. They can take a long time to build. You touch one thing, you have to rebuild the whole thing again. You can't build them in parallel because it's a single translation unit. The list goes on and on and on. This is a pain point that we've been dealing with. So in C++ WinRT 3.0, hey, you would replace that include statement with an import statement. This is the new story. This is probably going to be the way we're developing software more and more. Modules, I'm convinced after this exercise, modules are kind of going to be the future. It's great. Instead of a heavy snapshot of the compiler's internal state, ASTs, macros, duplicate symbols, all the stuff that you get in a precompiled header, well, now you have this efficient representation of the module's exported interface, the metadata that you need to import it, it's just the stuff that you need, not everything else in the compiler internals. Instead of a monolithic precompiled header that gets built with a single thread and can't rebuild incrementally, you get multiple modules, one per namespace. They can all build in parallel. You can take advantage of multiple cores on the machine. You can rebuild them incrementally if needed. You can kind of pick and choose. In theory, people can share precompiled headers between projects, but it's kind of scary. A lot of people don't do this. It becomes even more of a monolith. It's just, it's pain. Going to modules allows you to, pre-package, pre-compile a lot of your library code and a lot of your dependencies, and you can share them, incrementally, piecemeal, in a much more efficient way, and it takes up vastly less disk space. So this is the result. With multiple projects, you get bigger wins. They add up the more projects you convert. So when I did terminal, first thing I did is I built a module builder project that generated and built all the C++ WinRT modules for all the window types in the entire Windows SDK. I'm not even trimming namespaces. This is the equivalent of including every single WinRT header that you get from generating a platform projection. It's huge, right? This takes about 60 seconds on my one test machine, about 40 seconds on another. Generates about 700 megabytes of artifacts, but that's less than a third, less than a fourth, really, of the size of an equivalent precompiled header would be. Terminal, when I converted Terminal, it uses the WinRT types in WinUI and WebView too, so I was able to add those up front to the module builder project. Then I started switching the individual projects to import modules instead of including the headers. You use project reference to do this. That upfront cost of the module builder paid for itself pretty quickly. On wall clock time, it took about 3 projects converted before I started breaking even, and I got those wins back. As far as disk space is concerned, I got those disk space wins back after converting a single project. Like I said, a single precompiled header that makes heavy use of C++ WinRT is easily over a gigabyte, sometimes 2 gigabytes. Those shrunk down to just a few hundred megabytes each, compared to the 700 megas of built modules. Immediate wins on the disk, and as I continued converting more and more of the project, more projects, more tests, things like that, the disk footprint got smaller and smaller and smaller. Once again, this was strictly just change CPP WinRT to version 3.0, adopt modules, see how it runs. Didn't try to do any other improvements. This is pretty close to apples. So what's going on with these modules? Why is it so much better? How are we getting these wins? Well, when you generate modules with C++ WinRT, in addition to the headers we've been generating all along, we now also generate a module interface file, also an IXX file, alongside each projection header. You can still include these headers. There's some caveats to that. We'll get to that later. But I fully expect people are going to adopt this feature, gradually, incrementally in their code bases. Nobody likes to see a pull request with 800 changed files and thousands of lines of just boiling the ocean. Nobody wants to see that. So you can still include your headers. They can coexist. Each module, defines WinRT impl build module. It's a macro that controls some configuration behind the scenes. And then it includes the headers that you traditionally generate and selectively exports things in order to make the module work. Each module name, is named pretty similar to how the headers were. So like for Windows.Foundation, the module name is now winrt.windows.foundation. All the stuff that was in base.h, all the support library stuff, that has been renamed to winrt_base. Notice we use winrt dot for namespaces, and then more internal things that aren't associated with a WinRT namespace, we use the underscore, so WinRT base. So you can get all this stuff there. So that's kind of what's going on. If you want to apply this to your project, and this is what I had to do for Terminal, there are some prerequisites to get out of the way. Boring. We'll get on to the good stuff, but this is the first thing you got to do. You got to be using Visual Studio 2026, aka the Visual C++ V145 toolset. Maybe some genius is going to figure out how to make this work and backport it to VS 2022. I ran into difficulties and ran out of time, but it was working great in 2026. That's kind of the way we're going. So use that. Obviously, you need to be using C++ WinRT 3.0 or greater. That's where this feature lives. And since modules are a C++20 feature, you need to set your language standard to C++20 or greater. Kind of obvious, but getting that out of the way. So what do I do with Terminal? Well, first thing we do, like we said, I made a module builder project. Here's a little snippet of what the VCX project looked like. First of all, you'll notice it's a static library. We don't need to generate a new executable or DLL or anything else like that in order for these modules. It's just a simple static library. There's probably other ways you could do this, but static library was nice because one thing it gives you is the ability to sort of auto-magically share these built module artifacts with other projects that consume it via project reference. MS Build gives you that more or less for free when it's a static library. So it says, you use these built module files, aka IFC files, to build this project, and you're depending on it. Well, I'm going to make sure you can see those IFC files. That's going to be in your directories. You get that for free. It's convenient. It's easy. Just go that way. The next thing we have here is CPP WinRT build module. That's a new property in C++ WinRT. The targets files will then say, I need to generate IXX files. It changes the command line arguments. It'll add those to the to the compile step to make sure that we build those IXX files, those module interfaces, into compiled module IFC files. And then finally, since we're using modules all the way down, there's a standard library module. We're going to go ahead and use it. We don't pound include vector and all the other headers when you're in a module. We import std. Your project's going to need build STL modules set to true in order for it to generate and build that stuff. Maybe someday that'll be an automatic default and it just does it all the time. But for now, this is a manual setting you have to opt into in Visual Studio. So we're about to show you the code changes you need to make. And it's going to be very helpful to keep these sort of 3 constraints and lessons that I learned while doing the conversion. I am not a C++ 20 modules guru. I have hardly used them before I did this project, this feature. So these are the lessons that I learned that helped kind of guide a lot of the decisions I made when converting the individual projects. First thing I found was, I was like, okay, let's change all these pound includes into imports. Great, build. And I immediately got a compiler ICE, internal compiler error, in other words. Doing imports inside of a precompiled header doesn't work. On further reflection, this does kind of seem like an anti-pattern. I doubt that the Visual C++ team is ever going to officially support that. I don't see why they would. I have filed a bug saying maybe this should be a diagnostic, say you can't do this, rather than like internal compiler error. But don't do this. This means you have to lower or hoist, I don't know what the word is, but you need to take those statements out of the precompiled header, and they have to be then imported individually in each of your source files. There are some techniques to make this less tedious than it sounds, I promise. We'll get to those. The second constraint, you can include a header and then import the stuff from that. It is redundant though, because you're going to pay the cost of parsing the header, and then you're also going to pay the cost of building that module up front. So you can do this if you need to in a pinch when you're like in the process of moving stuff around. But that's not the state you want to live in, because you're paying this cost twice. It's erasing the wins we're trying to get. For a small header, small things that compile very quickly, this is not really as big of a deal. But these big C++ WinRT headers are big, expensive to compile. Don't do the work twice. Then the third constraint that we have is import then include. Well, that just doesn't work on MSVC. If you import a bunch of stuff from a module, and then you include a header that also defines those same identifiers, variables, types, functions, it's going to give you type redeclaration errors. It's going to say, this is a problem. This is not something unique to C++ WinRT. This exists in the standard library. You can't do this with the std module. But sometimes you're stuck with code that wants to do this, like external library code that's going to include these headers, and you've already imported them into the current translation unit. So C++ WinRT gives you an escape hatch. If you define this macro, WinRT import module, that essentially nullifies all the headers. When you then include a C++ WinRT header, it's going to define that header guard that avoids dual compilation, and that's it. It introduces no new types into the system. So yeah, you can import then include, as long as you define this macro first, and the macro makes it so that the include essentially is a no-op. It does nothing. So you still can't redefine the types, but at least you can deal with code that insists on including the WinRT headers, and you can make forward progress and get your projects converted. So that's how we go. This escape hatch, remember this is important. We're going to be using this. I use this quite a bit in the terminal conversion. So we're ready to go? There's 4 steps that I found, as I was converting each project. I had an agent help me once I got started and kind of figured out the problems. It was able to be somewhat automated. Things went pretty quickly once I got these patterns under my belt and fed to my agent. So remove WinRT headers from the PCH and replace with imports. We've already hinted at that. Dealing with code that still depends on including the WinRT headers, like will and other libraries. We've hinted on that. Intersecting the XAML compiler. That's a fun one. That's really a special case of the number 2 wrapping code. But I'll show you why it's a special case, why it's a little bit tricky. And then finally, in a large enough project, you might start running into like duplicate module references. Like you have Windows WinMD files that have types here and WinMD files that have types here, and you bring them both in, and you're both including IFC projects from all these static libraries, and it might start to complain that they're getting ambiguous. You can filter these namespaces we have properties for that in C++ WinRT. It'll still generate projections, still knows about the types, but it won't generate the module interface files and compile them for you. So this is how we deal with them. So here we go. Ready? First step. Convert those includes to imports. All right. So what we have here is we have your pch.h on the left with an include statement. We're going to remove that. As we said, you can't replace it in the precompiled header with an import statement. That breaks. It's an internal compiler error. So what I ended up doing was I hoisted all those includes first into a module preamble header. That's what I called it, module preamble.h, and converted them to imports over there. Then in all of my CPP files in the project, all I needed to do, instead of splattering a whole bunch of import statements all over the place, creating a bunch of noise, making the eventual merge of this pull request more difficult, now I just have a single line, include module preamble.h. Great. That gives me all the imports I need, all the stuff that all these WinRT types I used to get from my precompiled header. Now they're in the module preamble. Great. Fantastic. So step 1, done. We're there. All right, step 2, oh no, we got some errors because like Will or some other library, it's like some of these helpers have disappeared. I found that Will, if you haven't heard of Will, fantastic library, lots of useful headers dealing with Windows APIs. But they have some headers for C++ WinRT types. They have helpers that they define. They're very polite in Will. They don't include files on your behalf. They wait for you to include files and then try to detect if those types exist and then define helpers for them. How they're doing that is they're sniffing out the header guards that CPP WinRT emits. Like here's an actual sample from the Will headers. If defined WinRT Windows UI core. So, have they included WinRT/Windows.UI.core.h? Cool, I'm going to light up some helpers for types in that namespace. Well, we don't want to include, we've talked about this. This erases our build time wins. What are we going to do about this? Well, put those library headers in a wrapper that combines import to get the types, define WinRT import module to nullify the headers, and then we're going to go ahead and include WinRT headers so those header guards get defined, and so that this library will now be aware that these types exist and the namespace exists and we can use them safely. And then go ahead and include, in this case, Will CPP WinRT helpers. Include that library header. And then in all the places where you used to be including, this library, go ahead and include the wrapper header instead. Once again, since we're importing, if these things exist in the PCH, you're going to have to hoist them out of the PCH and have them processed in the individual source files. So, next up. Intersect the XAML compiler. This is basically the same idea. The XAML compiler generates code that has #include WinRT, some namespace, XAML related stuff to make things work, to power bindings and whatnot. I don't know. I'm not an expert there, but this is what it does. It generates this code. This is tricky. The files don't exist on disk, and they're regenerated every time, so you can't edit the file directly. It's dynamically compiled. It's not added to your VCX proj. It's built during a separate step that like WinUI hooks up. And so trying to change how that thing is built like statically in your project also doesn't work. MSBuild misbehaves if you try to like change properties on things that aren't actually in the project, and that don't exist yet. So what do? Well, we have to intercept it. This is simplified code. Don't use this verbatim. We've documented the actual stuff, more thoroughly on the C++ WinRT site. But essentially, you set up a custom target or two that intercept when the XAML compiler is done generating the files, but before it has sent them off for compilation. And we use forced include files, which sets /fi on the command line for the compiler, which forces your module preamble header to be included right at the very top of the file. Great. This means like, now we can do the import, we can define WinRT import module to nullify the header files, and now this XAML compiler generated stuff can happily go on its way. It is kind of a gnarly workaround. The good news is that the XAML, I've talked to the folks on the XAML compiler team. They're planning an update to detect that C++ WinRT is operating in module mode and do the right thing and change the code that they emit and emit import statements instead. They're working on that, so someday we won't have to do this anymore. But in the meantime, we have this workaround. But like, this is somewhat well known and expected, or it's going to become well known after this talk, right? Finally, step 4, you might run into duplicate IFC files. This is what module interface files compile down into. This can happen if, as we mentioned earlier, if you lifted up things like WinUI web view into your module builder project so that you can also compile those modules once and forget about it. And then later on, some other project is consuming WinUI. You're going to have built module files from both sources. It's going to complain that it's ambiguous. This isn't like header files where it just finds the first one that it found in the search path and uses that. It's going to say, these are ambiguous. What do you want me to do? So usually the way I solve that in terminal is I would use new properties in C++ WinRT, CPP WinRT module include, CPP WinRT module exclude, to exclude and filter certain namespaces from the module generation. This is very similar to the existing namespace filtering that we have in CPP WinRT for headers. It's just this lies on top, and it strictly controls only the module interface file generation. So if you've used this before, you'll know how it works. You're familiar with it. Just do this to filter the specific module file so we don't get ambiguous IFCs. So like in terminal, I would add Microsoft.UI to the excluded namespaces. That way I wouldn't get duplicates. Anyway, moving on. At the end of the day, and that's it. I was able to train an agent to do all this. We get massive build wins. It runs faster. A couple of my colleagues that work on terminal, we were testing it out and seeing how much faster it was, and they're I won't quote exactly, but it's wholly expletive. You built terminal in 7:30. That's wild. This is good stuff. These are meaningful impacts. Yeah, C++ 20 modules. They've been a long time coming. There's a lot of technical, complexity and difficulty going in there, but I've come out of this. This is the way to go. This is the way we're going to author libraries in the future. It's a vastly cleaner development experience, and when it comes to like really heavy, complex header files like C++ WinRT, you can get meaningful, impactful build wins that matter. It's going to save you money. It's going to save you disk space. It's going to save you time. This is great stuff. So I'm looking forward to hearing about more projects besides Terminal adopting this feature, upgrading to C++ WinRT. Looking forward to getting feedback on the project, seeing what we can do to make it work even better, and make the adoption process less painful and remove friction from this adoption process for more of our customers. So looking forward to hearing from you. And that's the end of this talk. Here's some resources for you. Here's a link to the repository as well as the modules documentation that I've mentioned that has all the 4 steps I've been talking about, but in much greater detail, and tells you exactly how to massage each of these properties and how to adopt it into your project. So thank you. Thanks, and have a good day.
Well, thank you for that. We were talking about this before. We saw in the comments there was someone suggested, hey, maybe Visual Studio or some tool could help migrate to using modules to make that easier. So let's chime in. Let us know what you think about that. Would you have some tooling to make that easier for you? Let us know.
Yeah, and I think in general, modules is definitely top of mind for a lot of C++ developers. It's a great migration that can help you optimize your runtimes and your builds. And so I think being able to modernize your C++ code base and sort of seeing this actual case study is definitely really helpful of how Microsoft itself is adopting sort of the latest C++ standards. And so great to see Ryan's presentation on sort of his learnings along the way and how he migrated to modules, and maybe that is something that can be streamlined in the future. So looking forward to sort of hearing from the developer community and seeing where we can improve there. And so I think with that's our last session of the day.
It is, yeah. So make sure that if you want to play around with all this stuff that you saw today, download the latest version of Visual Studio. Go get the Copilot CLI. And the C++ dev tools for VS Code, and you can try out all this good stuff today.
Yeah, and if you sign up for GitHub Copilot, there's a free trial and a free SKU, so you can always try it out. No credit card required, and see how it works for your agentic workflows. So definitely recommend trying it out, letting us know. We're active on all of our social media channels and on DevCom, and so if you have any feedback, we'd love to hear it. Your developer feedback really helps us shape our products and where we improve in the future. And so really important to us in general to hear from our developer community, and really appreciate everyone's attention today. And so I think this is all recorded. So if you want to, check some of the sessions later that you might have missed, it'll all be available on the YouTube playlist for Pure Virtual C++. So recommend if you want to check a session out again, it'll all be recorded for you to be able to reference again.
Yep.
And so with that, thank you so much for attending, and I hope you enjoy the rest of your day.
Thank you, everybody.
Thank you.